Bismillahirrahmanirrahim. Assalamu alaikum. Welcome back to my YouTube channel and welcome back to the CREST conformational analysis series. As you would have seen in the previous videos, we learned about CREST, how to do a conformational sampling with CREST, and then how to make input files for Gaussian or Orca software to run your NMR calculations. You would have noticed that in the previous video, when I told you about making all these conformers and their calculations, um, there was something that we made a calculation of optimization at a certain level of theory, and then we did optical rotation, or we did the NMR at a certain different level of theory. So I couldn't tell you about this process in that video. So this is basically a database of NMR solvents and different parameters for that uh, to get good match between the experimental and the computational chemical shifts. So the website for it is this CHESHIRE I'll put it on in the description of the video as well. So for especially for natural products, so this group has done quite a bit of work on it, and they have made some scaling factors to scale your NMR shifts so that they can be they can match well with the experimental chemical shifts. So if you come to this website and then you come to scaling factors, so they have given scaling factors for different kinds of calculations, different solvents. So I was doing my calculations in chloroform. So that basically chloroform, how do you know your solvent? The solvent in which you have the experimental NMR. So that is your solvent. So let's say I was doing chloroform, and if you look at chloroform section, you see that it says that gas and solvent phase DFT methods in G09, and then it tells you about the methods, and then NMR using which setting, and then scaling factors, and then it tells you about the performance. It also has the root mean square deviation value and the standard deviation and the value of R square. So you can choose whatever suits you the best, but I chose, which one was it? I think it was B3lib61 plus CD with MPW1, PW91. It was probably this one. That was because of its low RMSD value and very good value of R square and low value of the standard deviation as well. So that's why I chose it, but you can choose whatever you want. So that's for HNMR, and then for carbon NMR, you can see that this method has a really good RMSD value. There are some which have like 3 or even more, but I chose this method. You can choose anyone. So basically, what it tells you, if you just go a bit up, that's the thing, that the website is a bit old-fashioned, but you can see that these are the scaling factors for hydrogen and C13 NMR, and these are the methods: geometry and NMR. So first one is geometry, and then the second one is the NMR. So it tells you that you optimize your molecule at this level of theory in gas phase, and then you run your NMR at this level of theory in with NMR is equal to GiAO, and then you use the solvent SCRF, like chloroform in this case. And when you have the NMR, then we will use these scaling factors for it. So basically, that's what I did. If you look at the calculations, you will see that we have the optimization at the level of theory, which was told here. And then that was in gas phase. And then later on, we had the MPW1, PW91, NMR, which you can see at the bottom. So it didn't have optical rotations, but I added it myself because I found through my experience that optical rotation is a really sensitive value to the molecular structure, and it really gives you. It's not a very long calculation. It takes less time, but it gives you a good idea of comparison of structures. Like if you look at two structures and they got same optical rotation values, it means they are same, they are identical. I mean, you can then look at the energies and the structures themselves, but this is a it gives you a quick idea, so it doesn't do any harm to put it in the calculation, and you have to give the wavelength at which you are measuring the optical rotation of the molecule. So this was about the website, like how you get all these methods. And once we have the NMR, so the calculations are done. We got all the calculations. If you look at it, sorry, wrong window was open. So if you look at the calculations, it has the optimization, and then this is the optical rotation and the NMR of the molecule. And if you look at it, we got the NMR in all of them. Now we need to extract the NMR data. If you look at the NMR, for example, this molecule has the NMR values, and if you look at like carbon, hydrogen, or all the others, and then you look at the labels like atom number two, so this is the chemical shift of atom number two, and then you can see that carbon number one, and so on. So this is the atomic numbering given by the Gauss view or Gaussian, but you might have a different atomic number in the experiment. So we'll learn about how to uh, gather these two things together and then compare them in the form of a table. So this was basically about telling you about this website, how I use the methods, and now I'm going to use this slopes to in my Excel sheets. So what we do is, if you just remember that we got this website from here, and then uh, if you go to general information, it tells you the method, how you use it. So you use the intercept and the slope value, and this sigma is basically the shielding tensors that you get out of the Gaussian file. So you use this formula to calculate the chemical shift. So chemical shift is the value of intercept minus the shielding tensor you get, and then you divide it by minus slope value. And if you come back to the scaling factors, you can see that you have got the slope and the intercept values for both hydrogen and carbon NMR, and you will use the values for which you use the method. So let's talk about that now. And looking at the video length, I don't really like to make very long videos, so I'll keep it for this video, and then I'm going to record a next video now for telling you about how to use these scaling factors and how to extract the data out of these files and combine it together, and then like get a publication quality final tables from it. So that's very important to watch the next video, and see you in the next video. Thanks and bye.